Hey there, STEM chemistry students. This is Ms. Ruark. We are getting ready to learn how to name molecular compounds, which is a completely different way of naming things. Considering we've just learned ionic, you have to do this completely different. So make sure that you understand the difference between the two. Well, in order to know the difference between the two, first we have to know, well, what's a molecular compound? A molecular compound is a covalent bond. Oh, what in the world is that, Ms. Ruark? Well, a covalent bond is what happens when atoms share one or more electrons with each other to form the bond. Now, we had talked about electronegativity, and that's the pull on shared electrons. Well, here in a covalent bond, that's where that sharing comes in. All right, when they share when they share electrons, each atom is going to be left with a full or complete outer shell, which makes them happy. All right, a covalent bond is going to be formed between two non-metals. Okay, so how can you tell if it's an ionic compound? Ionic means that it has a metal and a nonmetal. So you're looking for that metal, right? Or it has polyatomic ions. And if it's a covalent compound, it's going to be a nonmetal and a nonmetal, or many nonmetals. All right, so for example, if you have two hydrogens that come together, you would end up with H2 because you have two hydrogens, right? All right, if we have and let's show this. We have hydrogen with one valence electron and hydrogen with one valence electron, and guess what? These guys share. So we would draw this as H and H sharing. Look how happy they are. Okay, what about hydrogen and oxygen? Well, if we had hydrogen and it has one valence electron and oxygen has how many? It has 6, right? All right, well, hydrogen has one. Look, they're going to share, but oxygen's still not happy. So guess what? Oxygen has to pull in another hydrogen. Oh, yeah. Looky there. All right, so to make themselves happy, they end up as H with an O in the middle, and then they've got their other H. And you can draw it this way. You can draw it here. We'll get into the structure and the geometry of it in a couple podcasts. All right, what about chlorine and chlorine? So chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons, and we've got another one with 1, 2, 3, 4, 5, 6, 7 valence electrons. And look, if they share these, they'll each have a full valence electron shell, right? So they would be sharing 2 electrons with each other. Oh, how sweet. I know, we like it when they share. All right, and there's your chlorine atom, or a chlorine molecule, excuse me. All right, so you've got 3 more here. I want you to try these on your own and see how you do. Okay, when you come to class, remind me, we're going to check these, 4, 5, and 6. Okay, naming covalent compounds. So how in the world do we name these things? Well, and when you name them, you have to have the IDE on the end, just like you do when you name an ionic compound. And each element is going to have a prefix on it. Now, remember, a prefix is what comes before the word, and the prefix is going to tell us the number of atoms. It does not tell us the charge. Now, remember, when we did ionic compounds, we had Roman numerals, and those Roman numerals told us the charge on the metal. Okay, that's the charge. When you get to prefixes, that tells us the number of atoms. It does not tell us the charge because they're not charged. They're sharing. Okay, so what are the exceptions? Well, the only time that we don't use a prefix is on the very first atom, and that's only if the prefix should be mono. Okay, so we don't say monocarbon monoxide. We just say carbon monoxide. Okay, so we don't use mono on the first element. We use all the other ones, di, tri, etc., but we don't use mono on the first one. We do use mono on the second one. Okay, and here are your prefixes. You should have them on your podcast notes. All right, and you do have to memorize these. Sorry. Yes, you have to memorize these. This is usually the one that gives everybody the biggest problem. Why? I don't know, but it is. All right, so we drop mono for the first element, and the first vowel is often dropped to avoid the combination of vowels, such as OO together, like monoxide. We would drop the first O, so it would be monoxide. Pentaoxide, we would drop the A, and it would become pentoxide. Okay, so you drop the first one to avoid vowel confusion. All right, so for some examples here, we have one carbon and we have one oxygen, right? One carbon means mono, so we would say this is monocarbon monoxide, right? But we don't use, well, let's fix it. Monocarbon monoxide. Okay, but what are some issues here? Well, first off, we don't use mono on the first element. We just don't do it. It sounds stupid, right? No, it's not. It's assumed that if we say carbon, we know that there's one. Okay? So if we say carbon monoxide, well, it still doesn't, it's not fitting right. And the reason for that is because we have to avoid this vowel confusion here. So we would take that out and it would become carbon monoxide. Okay, here, P4, so we have 4 phosphorus and we have 10 oxygens. Well, 4 would be tetra, and we would write tetra phosphorus, and then 10 is deca, but we don't want to write deca oxide because there's vowel confusion there. So we drop the A and it becomes decoxide or decoxide. All right, and then for our last example, here we have one sulfur, right? Do we write mono on it? No mono, so we write sulfur. It's UR, not ER. Sulfur, and there's 2 oxygens, so sulfur dioxide. And there would be no vowel confusion on that one, so yes, you would keep the I. All right, here are some examples, some more examples for you to try here on the bottom. You have those on your vodcast notes. So go on ahead and pause it real quick, come back and check and see how you did your answers. Okay, CCl4, you should have carbon tetrachloride. Carbon tetrachloride. For P2O3, you should have diphosphorus trioxide. And then for the very last one, we would have iodine heptafluoride. And remember, it's fluoride and not fluoride. Okay, hopefully you did well. Okay, what happens if we want to write the names of the well, we want to write the formulas, but we only have the name? Well, you got to be able to do both. All right, so first you need to identify the elements involved. And you're going to use the subscripts, not the subscripts, sorry. You're going to use the prefixes to help you determine your subscripts, right? Those are going to tell you your subscripts. That's what I was trying to say. Okay, so what does that mean? Well, nitrogen dioxide. How many nitrogens do I have here? I have 1 nitrogen. Di means 2, oxide means oxygen. So this would be N, oops, don't, yep, N1O2. Do we write ones? No. So we write it as NO2. Okay, dinitrogen trioxide. Well, that's 2 nitrogens and 3 oxygens, so we would write N2O3. We don't cross anything, we don't cross down, cross up, we don't do anything on this one. It's just whatever the prefix is, that's the subscript for that element. The only time you worry about the crossing up and all that is when you get to your ionic compounds, which we've already learned. All right, tetraphosphorus, that tells us there's 4 phosphorus. Decoxide is 10 oxygens, so P4O10. And then xenon, there's 1 xenon. Tetra means 4, fluoride is F, so it would be XeF4. All right, warning, before naming a compound, or before writing its formula, you have to determine if it is an ionic compound, if it's acidic, or if it's covalent. And the reason for that is because you name them and write the formulas differently. You have to determine that. If you try to do this without determining that first, you're probably going to get them wrong. All right, so Fe2O3, a lot of people would be like, oh, that's di-iron trioxide. Incorrect. Okay, why? Because this is a metal. And if the first element is a metal, it's an ionic compound. And if it's an ionic compound, you have to name it by ionic compound rules. All right, so metal first. Is it a transition metal? It surely is. And if it's a transition metal, we have to use Roman numerals, right? Yeah. All right, so you have to make sure that you follow the rules. Practice, practice, practice. Okay, so we would call this iron 3 oxide, or if you use the stock name, the traditional way of doing it, it would be ferric oxide. Either one. They're both correct. All right, and then this one right here, this is a compound. It is a neutral compound because it's a compound, not an ion. And just like we call H2O, we call that water, right? The name, the chemical name for it would be dihydrogen monoxide. All right, well, this would be nitrogen trihydride. However, nobody calls it by that name. And the reason for that is because this is just called ammonia. It's the common name. We call it ammonia. So memorize that one so that you know it. Just like H2O is water. We don't call it dihydrogen monoxide. We call it water. And so NH3, we're going to call that ammonia. And make sure you don't confuse ammonia, NH3, with ammonium, NH4, your polyatomic ion. They're not the same thing. All right, I think that's it. It sure is. I'll see you in class.